download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about half-life. Now, over time, the amount of radiation coming from a radioactive sample goes down. How quickly this happens depends on the half-life of the sample. Now, there are two definitions for half-life. One is the time for the count rate to go down by half. And the second one is the time for half of the radioactive nuclei to decay. So let's go through some examples of what we mean here. So the half-life of carbon-14 is 5,600 years. A sample of carbon-14 has an initial activity of 1,000 becquerels, or counts per second. What is the activity of the sample after 11,200 years? So we have an initial activity of 1,000. Now, after one half-life, which is 5,600 years, that will go down by half. So it will be 500 becquerels after 5,600 years. Now, we want to know how far after 11,200 years, which is two half-lives, because 5,600 times 2 is 11,200. So we need to go down one more. And then 11,200 half-lives, it will go down by half again, so it would be 250 becquerels. So you can see that in every 5,600 years, it halves. It goes from 1,000 to 500 and then to 250. So it randomly halves every 5,600 years. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. Now, you may also be asked to work out the half-life from a graph. So the first thing you need to do when doing this is you need to find the initial activity. And that is the time after 0 days, or the amount of counts or becquerels after 0 days. So that's here. So our initial activity is 80. Then we need to find half of that. And all we have to do that is divide it by 2, which is 40. So now we just go to our graph and we go from 80, which is on 0, and then find 40, which is half of the count or half of the becquerels, and then we need to find how long it took on the graph to get to 40. So we go to where it meets the curve, we head on down, and there's our answer. It's 6 days, and that is the answer. It's as simple as that. And it would work really wherever you go along the graph. So if you were to then start at 40 down to 20, which is a half again, you'd find that it would go to 12. 6 to 12 is still 6 days. So the answer would be the same wherever you go, but it's easier just to start at 0 and to go down from half. So now what I'd like you to have a go at then is answering these questions here, and then we'll go through the answers together. So pause the video now. Okay then, for question 1, if a radioactive sample has an initial count of 400 becquerels, what is the count rate after one half-life? Well, after one half-life, it will go down by half, so it will be 200. So the answer for I is 200 after one half-life. And then for II, it asks for 2 half-lives, so we're going to go down again. And from 200, half-life is 100. So II is 100. And then a third half-life, we're going to go down by half again, and it's now going to be 50. So I is 50. And finally, the fourth one, we're going to go down again to the fourth half-life. That's going to go by half again, so it's going to be 25. So for IV, you should have got 25. Now for question 2, the half-life of radium-226 is 1,600 years. If a sample of radium has an initial or original activity of 200 becquerels, what will be its activity after 3,200 years? So 3,200 years is 2 half-lives. So we need to go by half. And 1 half-life is 100, and then 2 is 50. So the answer for I will be 50. Okay, so let's just rub these out so I can write them up here for you. The answer for I will be 50. And then we want to find out after 4,800 years, which is 3 half-lives. Okay, so 3 half-lives here. We've got 25. Okay, so your answer for this one, for II, should be 25. And then III after 6,400 years, so that's a 4th half-life. So down by half will be 12.5. So III will be 12.5. Okay, so question number 3. Sodium has a half-life of 15 hours. If a sample of sodium has an original activity of 500, what will its activity be after 30 hours? So that's 2 half-lives. So 1 is going to be 250, and then 2 will be 125. So your answer for I should be 125. For I, 125. And then on to II, which is 45. So another half-life. So it's going to be 62 or 63. Around there, isn't it? So 62.5. So that should be your answer for that. And that is a 3rd half-life. And then finally, one more half-life, 60 hours. That needs to go in, then it's going to be 31 to 32. Okay, so I, 31 to 32. Okay, so finally, question 4, using the graph. What is the half-life of the sample in the graph? So we start at 80 as the initial. We know that half of that is 40, so we need to find 40. We go over from our graph where it meets the line and down, and it should be 6 years. So we've now looked at what we mean by half-life and how to calculate half-life by the equation or by using a graph. You can now practice loads of these with our quizzes and with our exam questions, and if there's anything you didn't understand, please do get into contact with one of our tutors who will be happy to help.